Welcome back. In today's part of the series, we will look at we are going to compare the four families of organic compound that we have been talking about in the past. So those four family members, remember they are the alkanes, the alkenes, the alcohols. Remember alcohols can also called alkanos, and the carboxylic acid, which can also be called alkanoic acid. So let's take them one by one. We're going to use ethane as the member of each. So for the first one, that is, we're going to use the member with two carbon atoms. So for alkanes, it is ethane that we are using. So ethane is the name. And remember, the molecular formula for ethane is C what? C2H6. And what about the split formula for ethane? Going to be, remember we are showing all the bonds. So this is the split formula for ethane rather. And then what do we say about this ethane? Number one thing we can say about it is about alkane rather. Alkane contains, if you will see that it contains only carbon and hydrogen atoms only. So it is a hydrocarbon. So hydrocarbons are organic compounds that contain carbon and hydrogen atoms only. So ethane is an example of a hydrocarbon. And you can see that all the atoms here, that is all the bonds between the carbon and hydrogen, and even the one between carbon and carbon, they are single bonds. So it means the bonds between the carbon atoms are all what? Single bonds. So this is another thing we can see. The bond between the carbon atoms in all the alkene family members are going to be single bonds. So let's look at the alkenes. We take a member as well. We are going to take the member with two carbon atoms. So it means we will look at the ethane. And ethane, the molecular formula for ethane is going to be C2H4. We'll look at this molecular formula very soon. And the displayed formula for ethane is going to be CH, another C, another H, and then another hydrogen atom and another hydrogen atom. Remember, if you count for this carbon, you have 4 bonds around it. And if you do the same thing for the other carbon, 4 bonds around it. So it means you are right. It has to be 4 bonds around the carbon atom. So just like the alkanes, this is also a what? A hydrocarbon. But unlike the alkanes, the bond between carbon and carbon is what? At least we have one double bond between a carbon and the next carbon atom. So that is what differentiates alkanes from the alkanes. So they have what? They contain carbon to carbon double bond. I think I should make it this way. They have carbon to carbon double bond. That is the signature for the alkenes. When you see carbon to carbon double bond, you will know that alkene is here. And that carbon to carbon double bond, I said that is a signature. So the real name for that in organic chemistry is what? That is the functional group. That's the functional group. We'll look at what functional groups are very, very soon. So again, alkenes, they are hydrocarbons just like the alkanes, and apart from that, they have carbon to carbon double bond that we don't find in the alkanes. So let's move to alcohols. So we want to use ethanol as an example. So ethanol, and then it's going to be C2H5OH. That is the molecular formula. And then the displaced formula is going to be CH, and then this H, and then this H, and OH. So this is our displaced formula for ethanol. And then what can we say about ethanol? Can we call this ethanol, can we call it a hydrocarbon? If you look at it very well, you see that we have an oxygen atom there. So it is not a hydrocarbon. So this telling you that all alkanol families, they are not what? Alkanol family is not a hydrocarbon family because it contains um, oxygen atom. And the functional group here, can you suggest or can you guess the functional group? So what differentiates this compound from the one above is this OH. So the functional group of what do you call it? The alcohol is what? Is OH. And functional group. Sorry. I wanted to write functional group. So functional group is OH. So they will have OH group on them. And the last member of the family, the last organic family member that we are considering today is the carboxylic acid. So the example that we are going to use for carboxylic acid is going to be what? Ethanoic acid. So ethanoic acid. And the the molecular formula for ethanoic acid, if you remember, Eth means 2 carbon atoms, so it's going to be CH3, the first carbon atom, COOH, the second carbon atom. The displaced formula for ethanoic acid is CH, and then we have carbon to oxygen double bond, and then to oxygen single and to hydrogen. So this is the displaced formula for carboxylic acid, that is for ethanoic acid, a member of the carboxylic acid. Of course, just like ethanol, it is also not a hydrocarbon. So it's not a hydrocarbon. That is, all alcohols or all ethanoic acid are not hydrocarbons because they contain oxygen atom. So this will make them something else that is not a hydrocarbon. And of course, you can see that this is what differentiates this compound from this one up here, and that is the functional group. So the functional group of carboxylic acid is COOH. Please don't forget, COOH is their functional group. For this, it is OH, and for the alkene, it is carbon to carbon double bond. Please don't say the functional group is double bond. The functional group is carbon to carbon double bond. So, and I think we are done with this part of the series where we are comparing the 4 families. I think let me add one more before we go, and functional groups. We have been talking about functional groups. So what is a functional group? A functional group is an atom or group of atoms in a molecule that dictates how the compound will react. So functional group can be just an atom or group of atoms. So when we say group of atoms, you can see it in the case of carboxylic acid. These are the group of atoms that make this one a carboxylic acid. The C, the O, and this H. So that is the group of atom that makes the functional group. For the ethanol, these are the group of atoms O and this H. So it can be an atom, it can also be group of atoms that determine how a compound will react. Yeah, although these four family members that we are talking about, they have different functional groups. They have different functional groups. It means they belong to different organic compounds. However, the four families, they are linked in one way or the other. For example, when we have alkanes, how do they link with alkenes? The alkanes, they are made from petroleum. So remember, petroleum, they occur naturally. So it means the alkanes, they occur naturally. We can get them from petroleum, we can get them from natural gas. And when you make your alkanes and then you crack alkanes, so when this guy are cracked, when you crack your alkanes, you will get alkenes from it. So alkanes they occur naturally, but when you get them and then you break them down by cracking them, we will talk about cracking very soon. So when you crack your alkanes, you will get your alkenes from them. So how do these alkenes, how do they link with the next family member, which is alcohols? I can call it alkanos, but IGCSE, they say it as alcohol. So I'll call it alcohols. So how do they link with the alkenes? When you um when you react your alkenes with water, so alkenes plus water will give us the alcohols. You can see how they are linking now. So we have our alcohol. The fourth member is what? Our carboxylic acid. So how do this carboxylic acid, that is, how do they link with the alcohols? So when you subject your alcohols to oxidation reaction, so when you oxidize your alcohol, you are going to get carboxylic acid. So that is how the four family members are linked to one another. I think that is enough for this part of the series. In the next series, we will look at the homologous series. Thank you.